Linear program example 4. All right, so this is for all you financial advisors out there. All right, so a financial analyst has a consultation with a client, and the client expects to have $750,000 in liquid assets for when she retires. All right, and so here are the bonds in which we can invest. So the company is Acme Chemical, provides an 8.65% return for each year, and will pay off for 11 years, and the rating is excellent. So that's what that information gives us. Okay, so the analyst believes that all of the companies are relatively safe investments. However, to diversify and to protect the income, we want no more than 25% in any given bond or any given investment. Furthermore, we want at least half of the money should be invested in long-term bonds that mature in 10 or more years. Okay. We also want Dynastar, EagleVision, OptiPro offer the highest returns, but we don't want any more than 35% of our money invested in these bonds. The analyst wants to determine how to allocate his client's investments to maximize her income while meeting their agreed upon restrictions. All right, so again, this maximize her income is giving us insight as to what is our objective, what are we trying to do. So let's set up the linear program. Step 1, define our variables. Okay, so I'm going to let x1 equal, now I'm not going to write just Acme Chemical, because that's not what x1 is. What x1 is the amount invested in Acme Chemical. X2 is the amount invested, might even spell that word right, in Dynastar. X3 is equal to the amount invested in EagleVision. X4 is the amount invested in micromodeling. X5 is equal to the amount invested in OptiPro, and X6 is equal to the amount invested in Sabre Systems. Okay, those are our variables. Let's think of our objective. Our objective is to maximize the income. Okay, well, the income comes from the return. So if the return on Acme Chemical is 8.65%, that means for the amount we have in, X1, we'll get 0.0865. Okay, that's the return for the amount we've put in, plus 0.095 times the amount we put in X2, plus 0.1 times the amount we put in X3, plus 0.0875 times the amount we put into micromodeling, plus 0.0925 times the amount we put into OptiPro, plus 0.09 times the amount we put into Sabre Systems. Okay, so this is, we want to maximize our return, which is equal to this function right there. Okay, but now there's constraints that we have. Okay, well, let's think of constraints. The first constraint is that we only have $750,000 to invest. So x1 plus x2 plus x3 plus x4 plus x5 plus x6 has to be less than or equal to $750,000. Another way to write this, summation of xi is less than or equal to 750,000, where I equals 1 to 6. Okay. Second constraint we talked about is that no more than 25% can be in any one fund. So that means we're going to say xi has to be less than or equal to $750,000 times 0.25, where I equals 1 to 6. Okay? So each individual xi, the amount we invest in each bond, has to be less than or equal to 750,000 times 25%. Third constraint we want to set up is that at least half of the money should be invested in long-term bonds. Okay, so long-term bonds are Acme Chemical, Dynastar, Micromodeling, and Sabre Systems. So that means the amount we put in each of those, x1 plus x2 plus x4 plus x6, has to be greater than or equal to $750,000 times 0.5. Okay, half our money has to be in these long-term bonds. Fourth constraint is the three bonds, Dynastar, Eagle Vision, OptiPro, has no more than 35% of our portfolio. So Dynastar is X2, okay, Eagle Vision's X3, and OptiPro is X5, has to be less than or equal to $750,000 times 0.35. Right? And there's our linear program. We've included all of the information we have, and now we just need to set this up in Excel.